So today we review for this midterm that we have in terms of cover chapter 1, 2, 3, and 4. And like I mentioned earlier, we will start backward. We will start with chapter 4 and going backward to chapter 3 and chapter 2. Chapter 1 mostly is a definition. I think you guys can figure those definition or look over the previous item. But I think one of the question that a lot of students have is probably this question here, in the sense of how would you guys uh, deal with this particular question, right? So we did this question, or we complete this question before I type it up. But again, I don't have the solution right now. So basically we do it right here is as we look at this, we do this as live as we can be, right? So again, so you guys probably have to help me out with your, with your calculator and stuff like that. So a computer password consider 15 characters. So we know that this thing here, we need 15 character, meaning we need 15 different slots to create this password, right? So 15 character repetition is allowed or all allowed. In how many different passwords are possible if each character might be any lowercase or any digit? So if remember looking at this thing here, what are the possible item that we can have? Remember for the letter, I told you guys for the letter, there are 26 letter, right? From A to Z, we have 26 letter in our alphabet. And for our digit, for our number, we have total of 10 different number, which is again, from 0 to 9. At each slot, you can only choose one number, which is there's only one single digit that you can choose, which is from 0 to 9. We have 10 different single digit, right? So if you look at this thing here, which is again the total possible item that we can choose for each particular slot, do you agree that for a total item we can choose at each particular slot is 36? Because 26 letter and 10 number. So in this case, this is what we have is, again, for A, basically this is what we have is, remember, basically we have 15 slot to create this password. And again, in each slot, what are the possible outcome or possible number at each particular slot? You have 36 different ways that you can choose one item. You can choose either letter A or number 7. You can choose any letter and any number for that particular slot. And because they say that repetition or replication are allowed, meaning we can choose A, 15 times, right? Or we can choose all A 15 times, which is not very secure, but it is possible, right? So in this case, as you can see, in order to do this item here, it's the same as 36 times 36 times 36, always all the same as 36 raised to the 15 power, right? 36 times 36 times 36 are the same as 36 raised to the 15 power. Because why is 15? Because we have 15 different characters that we need to include in this password, right? So looking at this thing here, they tell you that you have to write in scientific notation. And again, for scientific notation is basically, if you type this in your calculator, which is it is 36 raised to the 15 power. Do you agree that we have in your calculator for A, you should have this item as your answer, 2.21 times 10 to the 23rd. Again, your calculator is 2.210739 e to the 23rd. Again, e to the 23rd is basically tell you that it's 10 to the 23rd power, right? So again, if you type in your calculator, if you type in 36 raised to the 15, which is 36 caret 15, you should have 2.21 times 10 to the 36. Again, they tell us that they want two-digit accuracy, right? So again, two-digit, so decimal, which is again 2.21. So everybody see the first or in example 1A in terms of that this is the total item that we have, which is 2.21 times 10 to the 23rd, which is basically, as I mentioned to you guys, is basically they are 23 zero after this numbers here. Okay, and that's a lot. Last time in class, I think we just have in terms of trillion because there's only 9 character. I think last time we have. This one is 15, and as you can see, 15. That's a lot of number, right? I don't even know how many what that number call, right? This is basically just to have a rough 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We still have 5 more number left, which is again I don't even know how to call this number, but and now even that now the uppercase, some of the character had to be some special special character, right? Like a add or a store or a number symbol, right? All different symbol. But again, looking at this thing here, this is what we have in A. Because we have 36 character, we need to, I mean, not 36, 15 character, we need to take 36 raised to that. So question with A here, how we got that number. Now they ask you how many different passwords are possible if each character might be any lowercase. So now they restrict to just a lowercase. We cannot have any digit, right? So if we all restrict to a lowercase number, do you agree that for B, for the lowercase number, we only have 26 different letter? And looking at this thing here, we still have to take this 26 raised to the 15 power, because why is 26? Because now they separate, or they do not let us use any number. And if you do this thing here, which is 26 raised to the 15 power, because there are 15 slot, 26 raised to the 15 power, do you agree that you have 1.67725 9e to the 21? Or in this case, because they want 2 decimal place, then we have 1.68 times 10 to the 21 power. So again, this is your password only consider number, I mean letter, right? Only letter. This is your password can only consider only the letter. There's no number involved, meaning your password can be Johnson, right? Something in that. Johnson, that's only 12. No, 14. So Johnson A, right? So again, if you want to make your password in terms of just a letter. So looking at this thing here, question with A or B in terms that in A, we can use letter number. That's why we have 36 total. In B, we can only use letter. So we are 36 in A and only 26 in B. So in how many different passwords are possible if each character might be any lowercase letter or digit, and at least one character must be a digit? So this is what we mentioned to you guys last time, or this is what I mentioned to you guys last time is, remember at least one, right? For C, we need to have at least one digit, meaning your password got to have at least one number. So you have to have Johnson 1, Johnson 2, or something in that nature, right? So if you have to have at least one, how do we find the number of password that consider at least one of them? So to do this thing here, what happened with B? Do you agree that in B, we do not have any digit? In B, your password, whatever password that you create in B, that is just a total, your password only letter. There's no digit. And remember, at least one is, if we know that this much number, this much password does not have a number in it, we can eliminate that group of password to give me the other group of password that just have, or that have at least one digit, right? Or to be in short, in C, this is all you do is you take 36, because 36 raised to the 15, not raised to the 6. 36 raised to the 15 power minus 26 raised to the 15 power. Why? Because this is the total possible password you can have that include letter and number, minus this is the total password that you can all have in terms of letter, right? This is the total password that only has it. So total possible, again, I'm, because one thing is, I'm sharing I'm sharing my iPad, so is the connection sometimes is very slow or lacking in terms that is status. So sometimes I have the pop-up say that the connection is unstable. So I know it's a little bit status, but bear with me here. So basically, I know some of you guys probably hear the static and buffering, but it is basically, I have my laptop, and then I share the iPad to the laptop, so sometimes the connection doesn't work out as nicely as I wanted, like the PowerPoint. So that's why sometimes I don't share a lot in terms of this item, and I type it up, but because of this thing here is too long to type it up and make the animation. But looking at this thing here, in order for you to see, this is what you guys need to do. And ladies and gentlemen, this is what you want to type in your calculator. You want to type 36. You want to write 36. 36 to the 15 power minus 26 to the 15 power in your calculator. Okay, don't type the answer for A minus the answer for B, because in the answer for A and the answer in B, we round up already. And if you take the round up answer, you will get it wrong. But again, if you take this thing here and your calculator should give you 2.1939 e to the 23rd. Agree? Which is, again, you type in your answer, which is 1.29 times 10 to the 23rd. Question. Now, question so far in terms of A, B, and C, in terms of the number possible password that we can get. And this thing here, they ask you a computer generated password. The computer generate 15 random, each of them randomly are equally likely to occur to be any letter and any digit, which is 26 letter and 10 digit, repetition allow. What is the probability that the password contain all letter? So how do we find the probability of this password contain all letter? We just want to know the password that contain all letter. So again, probability of all letter. Do you agree that in order to find the probability, we need to know what is the total number of only letter divided by the total possible password there is? Do you agree that this is what we have in here in part B? in part B, this is the number of password that only letter divided by part A, which is this is the total possible password that we can get, right? Which is, again, this is what you need to type in terms of B to find the probability. We need to know how many possible letter there is, which is 26 raised to the 15 power. Why 26? Because that's all the letter there is. Divided by the total possible password, which is the total possible password is 36 raised to the 15. So in this case, again, if you type this thing in, 26 raised to the 15 power divided by 36 raised to the 15 power, do you agree that you have, did they say 4 decimal place? I think they asked you for 4 decimal place. Do you agree that if you divide this thing out 4 decimal place, 0.0076, if you take 26,
Yep.
if you take 26 to the 5th power, divide by 36 to the 15.0076, right? And ABC, last one, they ask you find computer require a pass 10 at least 1 digit. What is the probability? So how do I find the probability here? Oh, again, do you see for this item here for E, the probability of at least 1 digit is the same as the result in C, which is, you can take the result in C, which is 36 to the 15 minus 26 to the 15 power, divide by the total possibility, which is 36 to the 15 power. When you type in your calculator, just put in your parenthesis, right? Why do I use the 36 minus the 26 up here? Because remember, this is the possible item that have at least 1 decimal, right? At least 1 decimal. If not, you can do the other one, which is, as you will see, if you take open parenthesis 36 raised to the 15 minus 26 raised to the 15, close your parenthesis, divided by 36 raised to the 15. Do you agree that you get 0.9924? And again, this item is the same as, for those of you who say, oh, Mr. Tran, I took 1 minus this. If my two, again, if you take 1 minus this item here, 1 minus 0.0076, you still get this number right here, 0.9924. Because again, we throw away the password that just have the letter, because they ask us for at least one digit. So at least 1 digit, meaning we throw away all the password. The probability of all letter is 0.0076. So we eliminate that, we throw that away. The password that have at least 1 digit is 0.9924. Okay. So again, this problem, like I mentioned, we went over it last time, and the number a little bit smaller because we only need nine character. For this particular one, we need 15. So that's why it's a little bit bigger. Question here. All right. If you don't have question, let's take a look at the other one that a lot of you guys have question in your homework. And again, this one here is your homework question, and I just took it. It's in your review, so I took it out. And a lot of you guys sent me a question related to this, so I just might as well take it over. And again, if you're lucky, this question is on the midterm, you know how to do it, right? So this one here, they say 10 college students have applied for the internship at a local firm. 2 of them will be selected for the interview. All right. So again, there are 10 applicants. They only select 2, right? So this one here, they not even hire. They just select for interview. So in how many ways can this 2 student be selected for interview? So again, does the 2 student, does the order matter, right? Looking at this thing here, hopefully you guys see that they don't mention anything about order. They did not say first come, first serve, right? They did not say if I receive your application first, I interview you first, right? This thing here just say we have a pile of 10 applicants, right? And then we select 2. Doesn't matter which 2 to interview. So everybody see that this thing here, the order doesn't matter. So if the order doesn't matter, we know that this is due with a combination, which is the combination in terms of the because the, and I know a few of you got confused between versus combination. Again, for this particular problem, the order doesn't matter. That's why we're using combination, which is the C formula. If the order matter, they say, oh, we, and if the order matter, then we're using permutation, which is 10p2, right? So if you have this thing here, which is reminder, if you use your calculator, you have to math, press 10, and then do that item that we have. And again, looking at this thing here, do you see, or if we were to do this by hand, this is what we have, which is again, if you have your calculator, you can do with your calculator. Again, this thing here, do you agree that if you type in your calculator, you should have 45, right? 90 divided by 2, you have 45. So there are 45 different ways that you can choose 2 applicants. Everybody see that? Again, remember, you need to type in your calculator, you need to type in 10, you need to choose math, and you go to P or B, and you choose the formula NCO, right? So this is the total possible ways to choose 2 people from the group of 10 people. Everybody still with me in A? In B, they say 7 of the 10 students are from Middle Georgia State College. What is the probability that both of them will be selected for interview is from this state, Middle State Georgia State College? Express your answer as a reduced fraction or a decimal route to at least 4 decimal place. So reminder, in order for us to find the probability, the first thing we need to know is how many ways can we select 2 students from the group of this 7 students, right? So this is the total ways that we have, which is 45. Now, before we can find the probability, we need to know that if I have 7 students, I need to choose 2. How many ways is this possible? Which is 7 factorial, 7 minus 2. And there's a 2 factorial, which give me 7, 5, and 2. So 21, right? Again, I do this by hand. You have your calculator. You can use or type in your calculator. Everybody agree that this is 21. And again, that's not the answer, right? Because the answer, that's not the answer to the question, because the question asks you for probability. So to find this probability of 2 students from this college is 21 over the total, which is again 21 over 45, right? Which is, if you take 21 divided by 45, what did you guys have?
.4667.
667. So again, this is the probability. This is the probability that two students that you select from this college, from this Middle Georgia State College. I don't know why they named the college that way. It feels like a high school. But again, Middle Georgia State College, right? So I guess it's Central Georgia instead of say Central. Question with this thing here in terms of number 2, or in terms of this question. And let's take a look at number 3. This thing here go back to since we at chapter 5, and I don't know if this item since we at chapter 5 and this thing here relate to chapter 5, that's why I took this thing out. This is, we go back to chapter 3, which is they ask you to find the complement of the event. The complement of the event of this event here, and that's tricky, or the basically this is what you need to look at, or this is the word that you need to look at in terms of this item here. All right, and this word, as you will see when we get to chapter 5, when we come back chapter 5, we will see this word again. So remember this thing here, they don't want you to find the probability. They do not want you to find any probability or any number. They just want you to know that if I give you this qualifier, right? This is a qualifier statement. If I give you this qualifier statement, what will be the complement of this qualifier statement, right? So one thing is, remember when it's exactly 17, exactly 17 meaning this thing here, if I pick an x, if I pick a number for x, the x have to be equal to 17, right? If we look at this as in a algebra perspective, if I pick whatever number for x, this x, in order to be exactly 17, this x got to be equal to 17. Everybody see the word exactly, meaning there's no other number I can pick except 17, right? So the complement of this thing here, the complement of this item, everybody see that the complement of this item is, as long as x is not equal to 17, then it's the opposite of that, right? Is the complement of that. Everybody see in the sense that if we convert this to this algebra item, exactly meaning it's got to be equal to 17. The complement of equal to 17 is basically, as long as this thing is not equal to 17, we're good to go. And again, everything else is just a filler, right? The only thing that they want you to emphasize, or the only thing that they emphasize for this particular problem is this qualified statement. Is this exactly, at least, more than, fewer than, okay? And now think in terms of at least. What does it mean at least? Everybody see that at least, this is what at least mean, ladies and gentlemen. At least meaning I pick a number for x, and that at least 17 means that number have to be equal to 17 or more. Everybody see at least meaning equal to that number or more. So what is the complement of equal to 17 or more? Well, equal to 17 or more, the complement is basically tell you that as long as this thing here is, do you agree that as long as I pick a number less than 17, is the complement of at least 17? Everybody agree right here? If x is greater than or equal to 17, the complement will be just x is less than 17. As long as it's less than 17, as long as it's fewer than 17, then it's the opposite or the leftover. Is that making sense in terms of that we're using this inequality? Or am I going to a out of this RAM? Is it make any better understand of this wording than just looking at the word instead of just
I mean, I guess it's the way that you calculated the at least 17.
We are not calculate. They're not asking you to calculate anything. They just ask you, can you tell them what is the complement of this? And again, for this question on your homework is basically this one here. For A, the complement of this thing here is basically they say you that is not equal to the number of students is not equal to 17, right? They just basically ask you to, you click on it and choose one of the statement that fit the complement. And this thing here for A is basically not equal to 17. So the complement of at least 17 is basically not equal to 17. And the complement of at least 17, the complement of this thing will be less than 17 or fewer than 17. Or they say the other one, I did not mention this, but they have this thing here at most. The word at most, ladies and gentlemen, the word at most is the maximum that you can get. The word at least, that's the minimum you can get. The word at most, meaning that's the maximum number you can get. If you use an at most, this thing will be at most 16, meaning that's the highest number you can pick is 16. Okay. So again, less than 17, meaning you cannot pick 17, you can only pick 16, right? Everybody see that this idea here. And again, this is what I mentioned to you guys last time is, this is what I mentioned to you guys last time is, imagine that you have this number line, right? At least 17, this is 17, at least 17, meaning this is the group of number, a group of people that you have. This is the at least 17, meaning 17 all the way to 73. Now, what is the complement of this thing here? What is the thing that you did not include? Do you agree that you did not include this group of number here? What is this group of number? This group of number is from 0 all the way to 16. Do you agree that? Let's say that we have 70. Again, why do I say 73? Because I have 73 students. And basically from 0 student all the way to 73 student, this is what I have. And this is what they ask you for the complement is, okay, if I give you this blue ink, if I give you this description, at least 17, what does that mean? At least 17, meaning at least 17, meaning 17 and beyond, right? 17 and up, 17 and more. So that is included in the description of at least 17. What does not include in that description? Well, the only thing that does not include in that description is 0 to 16. So how do you write the number, or how do you write this, express this in English? Right? You cannot say from 0 to 16 because they don't want it that easy. So they wanted you to say less than 17. Meaning again, everybody less than 17, any number to the left of this 17 is less than 17.
I have a question.
Yes, go ahead.
So the answer for B would be X less than 17?
Right.
Okay.
Or fewer than 17.
Right.
Whichever one that they tell.
Okay.
Did you say that you had taken this out? Like this is not going to be on the midterm?
What's that?
Did you say earlier that you had taken this question out because it was like relating to chapter 5? Like it's not going to be on the midterm?
No, I say I took this thing out. I don't know if it's in the midterm or not. This is one of the midterm is in the review. I took it out because it could be in the midterm and also relate to chapter 5.
Okay, gotcha.
That's why I took it out so that we can see this word in more detail. I don't know if it's in midterm or not.
So basically complements are just like inverse operations.
In the nutshell, yes. Or in a nutshell, whatever left that you did not include in your description, right? That's the complement of it, right? So again, so in the sense of this thing here, just, you know, and that's the hardest part is how do we took this description and see what we have. And there are, and that's why one way that I do is one way that you can do is you can write it in the equivalent or in an inequality, and then write your inequality and tell you, translate to English in that way. Okay. More than 17. One thing is more than 17 is this item right here, ladies and gentlemen. More than 17 meaning, again, the whatever number you choose for X or whatever number you choose does not include 17, right? More than 17 is above 17. So more than 17 is basically X is bigger than 17. So what will be the complement? The complement will be X is less than or equal to 17, right? Because 17 is not in this group, right? If you were to draw your number line, 17 is here, but we do not include 17. Whatever more than 17 is up here, right? Meaning, again, the complement have to be from 0 to 17, because we did not include 17 in my blue ink. Again, more than do not include 17, right? More than meaning the 18, the 19, the 20, anything above 17, that's more than 17, right? What fit the description, more than 17, the 18 and everything else. So again, the complement of this thing here, if you were to write in English, is had to be at most 17. One thing is they will tell you is you can say at most 17, or less than 18. You can do less than 18, still fit that description, right? Because again, if it's less than 18, we include the 17. So basically you ask yourself, do you include that endpoint? Do you include this endpoint here? If you include it in the description, your complement does not include it. If you do not include in the description, then you have to include in your complement. Is that making sense? And lastly, hopefully now, what is the answer for D? Do you agree that this thing is fewer than 17, meaning X is less than 17? Right? That's fewer than 17, meaning the complement will be X is greater than or equal to 17, right? Or at least 17, right? So again, at least 17, basically at least 17 meaning 17 or greater, 17 or higher. Okay. So again, just think in terms of what is the description they give you, the complement have to include everything else, and it just in the sense of that. Question with this item here.
Hold on just 2 seconds and let me finish writing this last problem out.
No problem. I will post this on well, this is the exact question you will see on your item. I will post I guess I will post this note on Canvas right after class, so you can see my swirly handwriting. So I will post this exact item on Canvas. So if you don't have time to copy it out, you can check it out on Canvas after.
So for the complements, like it's like each one is the opposite of what it's asking.
Yes.
Okay.
What is the at most 17 over less than 18? That's
No. It's either or, not over.
okay.
It's either one or the other. Because on your homework or on Alex, for this item is basically you have to click on that. You have to click on that box where they have that drag down item, and then I don't know which description they give you. It's either one or the other. If you click on this thing here, they have like three items that you have to select. If they have at most 17, that's correct too, or it's either one or the other. It's not that
So they're not gonna have X is less than or equal to 17. It's gonna be like words like at most 17 or less than 18.
Yes.
Okay.
They will have the description, and that's why you have to translate the inequality to the word description. So it's either less than 17 as one option, or fewer than 17. This is another option. So again, those
So
are the
the
options
answer
that
to C, the answer to C is at most 17. And then the answer to D is less than 18.
no.
Oh,
The answer in C is either at most 17 or less than 18. It's either one or the other for, again, either one or the other for C. Okay, either one or the other for C. For D, the answer for D is at least 17. This is the D answer. All right, let's take a look at this item. And again, hopefully after this thing here, from here on out, probably hopefully will be a little bit easy going forward, because this thing go back to our probability, which is chapter 3. So we have in a survey, how many kids do we have in a survey? 46,154 women would ask how many kids, how many children they have. The result as shown. So again, they give you the description, they give you the information, excuse me, they give you the information over here. Now they ask you, what is the probability that the sample woman have 2 children? Round your answer to 4 decimal place. So again, looking at this thing here, as you can see, remember to find the probability of 2 children, right? Probability of 2 children. All you have to do is, again, how many 2 children we have, which is, this is the number of women that have 2 children. Agree? And again, if this is the number of women that have 2 children, what do we take this number and divide it by? Well, we take this number and divide it by the total, right? Which is, again, the total will be 46,154. And again, basically you can use your calculator and give them 4 decimal place. And reminder, probability, right? Probability cannot be bigger than 1, cannot have a negative, right? What is the probability of the sample woman have more than 4 children? Well, more than 4 children. Do you agree that more than 4 children? That's why they're using that word. Do you agree that more than 5 children is this group of number, right? This group of item is more than 5. Agree? Not more than 5, more than 4, right? Meaning, again, 5 children, 6, 7, 8 or more. Which is, now we need to take this number, this number, this number. We need to add those number up, which is, to find this probability, you need to take this number added to 9, added to 530, added to 775, and divided by the total. Agree? So again, those are the items that fit the description of more than 4, which is, again, more than 4 children, right? So everybody see that those are the more than 4 children. Assume that this is a simple random sampler of US women using the empirical rule method to estimate the probability that a woman have more than 6 children. Again, all of that wording is basically tell you that what is the probability of the woman have more than 6 children. So again, more than 6, do you agree that this number of women have more than 6? It's basically, they tell you that if we have this sample, can we take this sample to represent the whole population of the United States, right? So again, that empirical rule is basically tell you that if we have this sample, can we take this sample to represent the population? Since we don't have the population, can we estimate the population? But in the short, or in this item, more than 6, meaning the 7 children, the 8 children or more, right? Which is, again, we take that number and divide it by, we take that number 530 plus 775 divided by 46,154. Okay. Using the cutoff of 0.05, is it unusual for a woman to have no children? So again, in order for us to know if it's unusual or not, we need to find the probability of no children, right? So the probability of no children, do you agree that no children meaning 0? So we need to take the 12,000 535 divided by the 46,154. And again, if you divide this number and if this result is less than, if the result is less than 0.05, then we say it's unusual. If the result is bigger than 0.05, then we say that it's usual, it's not unusual. If it's not unusual, meaning it's usual. Everybody see that? So again, the result here, I think it's like 12 something, like 0.12 something, right? So basically this number, the result is not, this number right here for D, the result is bigger than 0.05, right? It's bigger than 0.05, therefore it is not unusual. Unusual, right? So again, so the result that you have, whatever this result here is bigger than 0.05, your cutoff item. So we know, we say that this is not unusual. Again, not unusual meaning is usual. It's pretty usual that the woman does not have any children. Okay. So question with this A, B, C, or D here.
You said you're gonna post this for view on Canvas, right?
Right.
Okay.
And again, is the exact question on your review in your Alex review. So you know, it's you can see it there. This one here, I don't think for this one item here is just basically tell you or ask you to see the scale of your probability. Just imagine that this is my A, B, C, D, E, F, and G, right? This is the option that you have. And if you did the homework for this item, if you did the homework for this item on chapter 3, you have this 2, 4, 6, 7 item that you need to choose to see which one fit the description, right? So when we do this thing here, this is what I mentioned to you guys, that, you know, thing in terms of probability is a scale, right? From 0 all the way to 1. If it's 0, if the probability is 0, right? If the probability is 0, what that mean? Well, if the probability is 0, everybody see that if it's 0, then that event will never ever happen, right? So again, this thing here, the answer for this item will be F, which is again, the event can never happen, meaning if your probability is at 0, we know that it will never happen, right? That's the two extreme in terms of this probability is if the probability is at 0, then the event will never happen. If the probability at 1, then this event will certainly happen, will always happen. So everybody see that this item here, this will always happen, will always certain that is happening, because if it's equal to 1, and this thing will never happen. So basically think in terms of your scale. If your probability is near 0, which is in this case, if this probability is near 0, everybody see that if it's near 0, meaning it's very, well, first of all, if you look at this outcome, we know that it's not going to happen, and it's not, and A will not be it, F will not be it, and G will not be it, right? And again, remember 0.02 is basically, remember the previous problem, how do we consider something unusual? As long as your probability is below 0.05, we say it's unusual. So in terms of this thing here, if you were to choose this option over here, if you were to choose any of the option over here, anybody see that the only option that we can choose that fit the description is this thing will be the unusual event, meaning the option E, unusual event here. Okay, so again, for this particular problem, it's just basically ask you, what can you choose, or what item fit the event that we have. Okay, so the two extreme that we have is basically the 0 and 1. Beside the 0 and 1, the other thing that we know, what happened if this were to be the case, what happened if the probability is bigger than 1 and less than 0? Everybody see that for this item, the answer will be G, because somebody make a mistake, right? Someone make a mistake, and your probability is bigger than 1 and smaller than 0. So again, those are the other item that you see that someone make a mistake, the probability cannot be those. Okay. Now the hardest thing is now what about the point 19? Well, the point 19, do you agree that, again, we know that the point 19, we know that it's not this thing here. We know that it's not unusual because it's not that item. We know that it's not this item, and we know that it's not someone that make a mistake. So now here come the problem is, how do we know that the event is likely to happen and is not? How do we know that the event might happen but is not likely? Or how do we know that the event is very likely to happen but is not certain? So those are your three options. And as I mentioned to you guys, is the closer to 0, the closer the event closer to 0, then it will likely not happen, right? So this thing here is basically might happen but not likely. Everybody see that for point 19, the answer will be C, because this event might happen but not likely, because again is near closer to 0. And what about 0.5? Do you agree that 0.5, this is 50-50, right? 0.5 meaning you have 50% of happen, 50% is not happening. So everybody see that for E, then we will choose the event is as likely to happen as not, meaning is 50% happening, 50% not happening. And lastly, what about this item here? What about 91? Well, 91 will be very likely to happen, but will not be certain, because again, in order to be certain, it has to be 1, which is that will always happen. But again, 0.90 is closer to 1, which is will very likely to happen, but not certain. Okay. And again, if you see this thing here, just think in terms of your scale, right? Closer to 0, not gonna happen. Like not likely to happen, right? And closer to 1 will likely to happen. Okay. And again, that is just the idea of probability. Let's go to 6. We move to chapter 2, or go down to chapter 2. How do we create this bar plot? And the reason why I picked this question is they might ask you for an IQR. They will ask you or might ask you for the IQR, which is interquartile range. Remember the IQR is Q3 minus Q1. Okay, the interquartile range, which is the IQR is Q3 minus Q1. So again, we will mention more of that. Let's take a look at this thing here. They give us Q1, which is quartile, first quartile Q1. Your median is your Q2, right? This is your Q1. And again, your third item, which is your Q3, which is everybody see that they give us the 3 Q, Q1, Q2, and Q3. So in order for you to create this bar plot, reminder that first of all, to create this bar plot, this is what we have is, let's say, let me move it down a little bit so I can use that too. So let's say that this is my number range. Let's say that I have 0. Let's say 50 is the highest, right? So let me do 60. So let's say that I have from 0 always to 60, and this is 50. And again, let's say 10, 20, 30, 40, right? So let's say that this is my number range. Reminder, the Q1, your Q1, this is what you do is, this is your Q1. Your Q1 is 21, right? Your Q1 is 21, which is somewhere here, right? Your Q3 is 33, which is 33. Your Q3 is right here. I mean, Q2 is 33, and your Q4 is 42. 42 is somewhere here. Reminder that this is what you have in terms of creating the box plot. Your box is include of Q1, Q2, and Q3. So for this particular one, they give you Q1, Q2, Q3. That is how your box is. Now, how do we find the endpoint? How do we find the whisker? And how do we find the outlier? Reminder, the first thing is we need to know is we need to find the lower limit. And your lower limit is basically your Q1 minus 1.5 times the IQR. So again, this is the formula for the lower limit, which is your lower limit is your Q1 minus the 1.5, which is the fixed number, times the IQR. And the higher limit, your upper limit or your higher limit, your upper limit is your Q3 plus the 1.5 times the IQR. Okay, so looking at this thing here, what is my IQR? And that's where the IQR come in, is the IQR. The IQR is you need to take the Q3, which is 42, minus the Q1. Everybody see that this thing will give me 21. Again, your IQR. Question?
Yes. That's a formula we're gonna have to remember, or is that gonna be notated?
There is, just like your test, there's a formula. If you click on formula, it will pop up the formula. And again, all the formula, you will have it on your test, which is there's a formula section that you click on and it will pop up the formula for you.
Okay, thank you.
Okay, which again, so looking at this thing here, they will have this lower limit, I believe. Yeah, lower limit and upper limit, they do have it. They will have that formula for you. So looking at this thing here, do you see that my lower limit will be my Q1, which is 21 minus 1.5 times 21. Again, just coincidentally that my IQR is 21 because 42 minus 21 is 21, right? So what is 1.5 times 21? Well, 1.5 times 21 is that 31.5. Is 1.5 times 21, is that 31.5, ladies and gentlemen?
21.5.
31.5. So if you look at this thing here, 21 minus this thing will give me a negative 10.5, which is, that's your lowest number that you can have, right? Meaning if your number is less than negative 10.5, then that will be your outlier, okay? But if you look at this thing here, what is the smallest data that does not exceed the negative 10? If we scan through, my lowest data is 9. If we scan through this thing here, my lowest data is 9, which is, again, that is where my last item is, which is at 9 right here. And my upper limit is basically, my upper limit will be 42. My upper limit will be 42 plus 31.5, which give me 73.5. So if you look at your data, you can see that none of your data is bigger than 73.5, right? So we don't have any outlier. But what is the highest data that did not exceed that number? The highest data we have is 50. So in terms of this thing here, you can see that this is my this is my, basically again, this will be your box plot, which is this item here. That will be your box plot that you have in terms of the box. We don't have any outlier because there's no number bigger than this item. So for instance, if this number were to be 84, then yes, we will have some outlier over there. We will have an outlier. But based on this thing here, we don't have any outlier. So there's nothing. Again, the lower limit and the upper limit is just for you to identify your outlier. Okay. So question with this IQR, question with this back plot. And let's do this thing here. Let's do this item and then we will see what we have. So this thing here, go back to chapter 3 again. Find the z-score for the ACT score. So looking at this thing here, reminder, again, your formula is there for you guys, but again, for those of you that don't remember, or if you have, or remember, the z-score is equal to the data minus the mean divided by the standard deviation, right? So looking at this thing here, they ask you to find a z-score for the ACT. So my ACT item, my item is, the mean is this number and the standard deviation is this number. So again, this is the data score, right? This is the data that I have. And to find this z-score, everybody see that all we need to do is take 24 minus the mean, which is 23.7, divided by the standard deviation, which is 2.5, right? So again, the data minus the mean divided by standard deviation, my data is the 24 minus the mean, which is 23.7, divided by the standard deviation of 2.5. And again, you can type in your calculator and find your z-score. And again, this z-score will be positive, right? So, and if you look at this item here, if you look at this item for the z-score of a SAT, for the z-score of a SAT, basically my data is 474 minus the mean of the SAT, which is 521, divided by the standard deviation of 104. You can see that this thing here is a negative z-score because this student, or whatever this score is below the average, which is, that's why it's negative. Okay. And if you look at this thing here, that is how you find a z-score, which is the data minus the mean. Now, if you want to find the data, reminder to find the data, this is what you need to do, is you need to take the mean plus the z-score times the standard deviation. I thought I can write smaller, but I cannot. Again, to find this thing here is the data is equal to the mean plus the z-score times the standard deviation. So if you look at this thing here, we got the z-score, we got the mean from our problem, we got the standard deviation. So if you look at this thing here, the score is equal to the mean for the ACT is 23.7 plus the z-score that they have is 9.2, and the standard deviation for the standard deviation for the ACT is 2.5. So again, if you plug this thing in, 23.7 plus 0.92 times 2.5, you should have the ACT score of this. And again, for Jose. And for Emma, if you plug this thing in, for the SAT, we have 521 plus a negative 0.05 or negative 0.5 times the standard deviation, which is 104. And again, looking at this thing here, we know that her score should be something below 2.1 because the z-score is negative, which is that's where your positive and negative come in. All right. So looking at this thing here, question would have to find the z-score or how to find the data given this item here. Any question, ladies and gentlemen? Well, I was not able to cover what I have. Well, let me cover one more, this item here. I'm running out of time, but let me do this one item and relate to the Chebyshev inequality. Reminder, the Chebyshev inequality, you only have two items, which is the 75% or the 88.9%. Those are the two percentages that you have. And if the 77% when your K is equal to 2, and if your K is equal to 3, then we say that it's 98.9%. 98.9%, right? So if you look at this thing here, they ask you again, they tell the temperature of this thing here, record each of the 2 months, and then they ask you with the K of 3. So if the K is 3, then you say at least 88.9% of the day have the temperature between these two items. So how do you find this two temperature? Well, to find the two temperature, you need to, again, because your temperature is your data. Your temperature is your data, which is to find the lower data. To find the lower data, this is what you need to do is you need to take the mean minus the z, or in terms of this thing here, the K, times the standard deviation. Again, the Chebyshev, instead of a z-score, they're using the K. So again, in terms of this thing here, to find the lower data, you need to take the mean minus the K times the standard deviation. To find the higher or upper data, then you need to take the mean plus the K times the standard deviation. Again, it's basically you find the data, it's just that now instead of the z-score, we're using the K. So they give us the K, all you need to do is plug it in, which is, again, we have the mean as 55.1 minus the K is 3 times the standard deviation of point. And again, if you minus, that's your lower endpoint or your lower value. If you add, that is your higher value, because again, to find this thing here, we need to know the group of items that is include 88.9% of your data. Okay, so looking at this thing here, this is the Chebyshev, which is we did this, that you either have a Chebyshev in terms of a K is 2 is 75%, or K is 3 is 88.9%. Okay. The other one, if you remember, the other one is your empirical rule, which is the 68, the 95, and the almost all. Okay, so again, I'm running out of time. If you have question, just send me an email or look over the old lecture. All of this thing here we went over already. I just take out what I think that you guys might still have problem with. And again, if you do, this item is in chapter 3. I think 3.3 to be exact, 3.3 or 3.4. So I am running out of time. So if you have question, please stay back. If you don't have question, reminder that your midterm is